Welcome to lesson number 4. We're going to talk about combinations today. So up until this point, we've only been talking about permutations. Alright, so as part of the grade 12 English course, students are required to read the following 3 books in a 3-month period: The Grapes of Wrath, The Wars, and The Bean Trees. So, due to previous late returns, Steve is only allowed to sign 1 English book from the school library per month. So list all the different orders in which Steve could sign out the 3 books. So if we're just talking about a matter of orders, then if we have 3, that's going to become 3 books, would be 3 permutation, or 6 different ways. Tariq is allowed to sign out all 3 books at the same time. How many different ways can he sign out 3 books at the same time? Well, for Tariq, if he's signed them all out at the same time, then the order doesn't really matter. There's only one way for that combination to occur. So there's only one way to sign out all 3 at once, because all you're worried about is signing them all out, not in any particular order. So a selection of a set of elements in which the order of the selection is not important is called a combination. Okay, so we're not concerned about order in this case. Remember, with Steve, he was concerned about order because on one hand, he could take out the Grapes of Wrath first, so I'll call that G, or you could take out the Wars, or you could take out the Bean Trees, or you could do it the other way around. And there were 6 different ways that he could take out one of the books first. Alright, so let's move on here. Suppose that the students of part 1 were required to read only 2 of the books. Complete the table to show the number of ways in which Steve and Tariq could do this. Alright, so let's see. We started with the Grapes of Wrath, the Wars, the Grapes of Wrath, the Bean Trees, the Wars, the Grapes of Wrath. Now, this is considering only reading Grapes of Wrath for sure. Now, he could also read the Wars and Bean Trees, or he could read the Bean Trees and the Grapes, if he's doing this in order, or he could do the Bean Trees and the Wars, because he only do one at a time. Now with Tariq, so still there's 6 different ways he could do it, but with Tariq he could do the Grapes of Wrath with the Wars, or he could do the Grapes of Wrath with the Beans, or he could do the Wars and just the Beans. But with Tariq's combinations, there's only 3 ways, and if you notice, the combinations are going to be similar to the permutations that Steve has. So if we look at how many options Tariq has, he has 3, whereas Steve has 6. So the number of combinations is going to be equal to the number of permutations divided by 2, or divided by 2 factorial. Alright? And it's pretty obvious here where there were 6 options, there was only 3 in this case. So again, a permutation is an arrangement of elements in which the order does count, but a combination is a selection of elements in which the order does not count. Now let's look at some examples. You can read that page on your own time, but I'm going to try and make a fairly short video today, so let's look at example 1 here. So I have 3 students from a class of 10, and they're chosen to go on a school trip. In how many ways can they be selected? And write the answer in factorial notation and evaluate. And so first of all, we have to look at our new formula that is up top here. We have a general rule where when dealing with combinations, and that is n combination of r, which is equal to npr divided by r factorial. All right, in this case, n is just our number of terms, and or the number of combinations, and r is the elements that are taken at a specific time. All right, so NCR can be thought of as npr divided by r factorial, or n factorial divided by n minus r factorial times r factorial. So 3 students from the class. Let's go to class example 1 again. So the number of elements is going to be 10, and the elements taken at any time, in this case, is 3, which is the same thing as saying 10 factorial over n minus r, so 10 minus 3, which would be 7 factorial times 3 factorial. All right, and so there's two ways we can input that into our calculator. We could say 10 math function 3 and 3 is equal to, we know that the answer will be 120, or we can type it in as 10 factorial divided by 7 factorial, 3 factorial. All right, and so I already kind of did that, and so what you should do is plug it back in like this. Now, number 2, to win the Lotto 649, a person must correctly select 6 numbers between 1 to 49. Jasper selected the 6 numbers from the birth dates of his family: 3, 7, 9, 11, 20, and 29. So how many different selections of numbers could he have made? Well, you must correctly select 6 numbers between 1 to 49, so that's the number of elements. So that would be 49. And the number of combinations that he has, because you have to have 6 numbers, 1, 2, 3, 4, 5, 6. You're selecting 6 at any one time. So it would become 49C6, or if we put that into a combination, there would be this many: 1, 3, 9, 8, 3, 8, 1, 6. So 13 million, close to 14 million different ways in which you can come up with different numbers. So you have, that's not very good odds of winning the 649 lottery. Now, the Athletic Council decides to form a subcommittee of 7 council members to look at how funds raised should be spent on sports activities in the school. There are a total of 15 Athletic Council members, 9 males and 6 females, and the subcommittee must consist of exactly 3 females. So determine the number of ways of selecting the females. Well, I have 6 females in total, and I have to have 3. So 6C3 is equal to 20. And how many males? Well, there's 9 males, and if 3 have to be females, then 4 would have to be males if I have a total of 7 council members, right? So it becomes 9, 4, be 126 different ways. Now, our subcommittee, the subcommittee must consist exactly of 3 females, and so same thing here, we'll have 6C3 times 9C4, which is the amount of men we have, or 20 times 126. 20 times 126, there are 2,520 different ways that these arrangements can be made. Now, in how many ways can the subcommittee be selected if Bruce, the football coach, must be included? Well, if this guy must be included, then that takes away one of the options for the males, right? So that the females will stay the same, but now instead of 9, it's going to become 8C3, and if we well, 20 will remain the same, but 8C3 is going to be 56, and 20 times 56 is equal to 1,120. All right, lastly, a standard deck of cards, 52 cards, has the following characters. There's 4 suits. How many different 5-card poker hands are possible? So 52, there's 50 cards, and we have a combination of 5. $2,598,960 different hands possible. How many will be all diamonds? Well, again, there's all diamonds. There's 13 diamonds you can choose from, and if I have 5 of those hands, 1,287. 4 cards, 4 black cards and 1 red card. Well, 4 black cards and 1 red card. There's 26 black cards to choose from. And I want to have 4 of those. And then there's 26 red cards to choose from, and I have 1 of those. And so you can calculate that, but that's the standard. Well, that's what the combination will look like. 3 queens and 2 queens. 3 kings and 2 queens. Well, there are 4 kings in the deck, and you want to have 3 of those, and 2 queens. There's 4 queens, and you want 2 of those. And will there be 3 kings and 3 kings? Well, again, there's 4 kings, and you want to have 3 of those. And then the rest of them will be non-kings, right? So that's 48 to choose from out of the 52 cards. And you want 2 like that. 4 aces. So if you have 4 aces, there's 4 aces in a deck. And then you would have, for the 5th card, you have 1 non-ace. 5 cards of the same suit. So that's called a flush. So that could be 5 clubs or 5 diamonds or 5 hearts or 5 spades. So there's 4 different ways to choose from that. So we would say that there's 4 different combinations of suits you could have. But to get that, there's 13 in each hand, or 13 in each suit, and 5 in each hand. So it would be 4 times 13, C5. And so if you just calculate all of those, you'll get the solutions to each of these.